Hello, students. I am Sir Glenn, your subject teacher. Welcome to Pre-Calculus. Our seventh lesson is all about the sigma notation. So, ano nga bang sigma notation? Para saan ito? Anong kanyang gamit? Malalaman natin yan under this lesson. The sigma notation is a shorthand for writing sums. So, definitely, shortcut yung sigma notation upang isulat ang sum, upang isulat ang isang series. Okay? In this lesson, we will see the power of this notation in computing sums of numbers as well as algebraic expressions. All about the sigma notation. Mathematicians use the sigma notation to denote a specific sum. The uppercase Greek letter E or the Greek letter sigma is used to indicate a sum. So, siguro karamihan sa inyo ay familiar na sa symbol na ito. This is the sigma notation. The symbol that is used for the sum, the sigma notation. The notation consists of several components or parts. Ano-ano nga ba ang parts ng isang sigma notation? So, sigma notation is a way of writing a sum of many terms in a concise form. A sum in sigma notation looks something like this. As you can see, so may andyan na yung mga parts niya. So, this is read as the summation of x of I from 1 to n. So, ano yung E dyan? That is the Greek letter sigma. It is also called the summation symbol. Itong part na to, this is the formula for the terms. Itong part na to, the lower limit, yung unang value ng ating I, and then yung nasa taas niya is the upper limit or yung last value ng ating I. Okay? The uppercase Greek letter sigma indicates that a sum is being taken. So kapag nakita mo na may ganyang symbol, automatic na sum yung hinahanap. The variable I is called the index of the summation. An x of I is a term or the summand of the summation. So yung I, yan yung index. Yung x of I, yan yung term or yung summand na tinatawag. Any letter can be used for the index of the summation. The letters I, J, and K are commonly used. So, kahit anong letter yung gamitin dyan, okay lang. Pero ang mostly used na letters ay si I, J, at si K. The numbers at the top and bottom of the sigma are called the upper and lower limits of the summation. So, nakita nyo na sa previous slide, ito ay yung lower limit at ito yung upper limit. This notation is read as the summation of x of I from I to n. Okay? For example, we have this notation, the summation of 3k from 1 to 5. In this case, the upper limit is 5 kasi siya yung nasa taas. The lower limit is 1, siya yung umpisa. Kapag sinabing upper limit, siya yung last na value na isa-substitute natin sa variable na ito. At yung 1, yun yung umpisa na value. Ibig sabihin, the notation means that we will take every integer value of k between 1 and 5. So, yung values na isa-substitute natin, yung mga numbers from 1 to 5. So, 1, 2, 3, 4, and 5. And plug them each into the summand formula. In this case, the formula is 3k. So, this is the summand. Then, those are all added together. So, it will be like this. The summation of 3k from 1 to 5 is equal to yung first value, which is 1, 3 times 1. We simply substitute that sa variable k. Yung second value, which is 2, 3 times 2. Yung pangatlo, 3 times 3. Yung pang-apat na value ni k, si 4, 3 times 4. At yung panglima, 3 times 5. So, simplifying this, we have 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 3 times 5 is 15. So, adding these numbers, it will give us 45 as the result. Understood? Example 1. Write each summation and evaluate the series if possible. For the solution, watch this video. In this example, we write each summation and evaluate the series if possible. So first item, we have the summation of k plus 8. This is 8 from 2 to 4. So by definition, kung summation siya, we substitute numbers from 2 to 4 doon sa variable na k. So let's do it. So we have, uh, since meron siyang specific value doon sa ating upper limit, we can evaluate the value of the series. Okay, so for k is 2, we have 2 plus 8. For k is 3, we have 3 plus 8. For k is 4, we have 4 plus 8. Since numbers from 2 to 4, there are only 2, 3, and 4. Tatlong numbers lang, kaya tatlo lang yung uh, na-expand natin na terms. Tatlo lang yung uh, elements ng uh, expanded na form. So, simplifying further, we have 2 plus 8 is 10. Then, 8 plus 3 is 11. Then, 8 plus 4 is 12. So, simplifying further, this will be 10 plus 11 is 21. Plus 12 is 33. So, the value of the series, we have 33. For the second item, we have the summation of 2 raised to I plus 1 from 0 to 5. So, substitute natin sa I yung numbers from 0 to 5. So, ilan yun? We have 0, 1, 2, 3, 4, and 5. So, there are 6 values to be substituted dito sa I. So, we have, the first one is 0. So, we have 2 raised to 0 plus 1. The second one is 1. We have 2 raised to 1 plus 1. The third one is 2. 2 raised to 2 plus 1. The fourth one is 3. 2 raised to 3 plus 1. The fourth one is 4. We have 2 raised to 4 plus 1. At yung panglima, we have 5. 2 raised to 5 plus 1. So, simplifying further, we have 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 4. 3 plus 1 is 4. 4 plus 1 is 5. And 5 plus 1 is 6. So, simplifying, we have 2 raised to 1 is 2. 2 raised to 2, or 2 squared is 4. 2 cubed is 8. 2 raised to 4 is 16. 2 raised to 5 is 32. And 2 raised to 6 is 64. So, if we add these numbers, 2 plus 4 plus 8 plus 16 plus 32 plus 64, the value will be 126. For the third item, we have the summation of j all over 4 from 1 to n. Since walang specific value yung kanyang upper limit, hindi natin ma-evaluate or hindi tayo makapagbigay ng specific constant for its series. So, ma-expand na natin to. We have, substitute natin kay j yung mga numbers between 1 to n. So, for n is 1, we have, for j is 1, we have 1 all over 4. Kapag 2 siya, 2 all over 4. Kapag 3 siya, 3 all over 4. Kapag 4 siya, we have 4 all over 4. Up to n all over 4. So this can still be simplified. We have 1/4 plus 1/2 plus 3 all over 4 plus 1 up to n all over 4. Okay, so ito na yung sagot natin. Since walang specific value yung kanyang upper limit, hindi tayo makakapagbigay ng specific value for the series itself. For the fourth item, we have the summation of k minus 2 over k plus 2 from 0 to 6. So, substitute natin kay k yung mga numbers na 0, 1, 2, 3, 4, 5, and 6. There are 7 numbers. So, if k is 0, we have 0 minus 2 all over 0 plus 2. Kapag 1 naman, we have 1 minus 2 all over 1 plus 2. Kapag 2, 2 minus 2 all over 2. Kapag 3, 3 minus 2 all over 3 plus 2. Kapag 4, we have 4 minus 2 all over 4 plus 2. Kapag 5, 5 minus 2 all over 5 plus 2. At kapag 6, we have 6 minus 2 all over 6 plus. Simplifying this, we have 0 minus 2 is negative 2, 0 plus 2 is 2, 1 minus 2 is negative 1, 1 plus 2 is 2 minus 2 is 0 all over 4, 3 minus 2 is 1 all over 5, 4 minus 2 is 2 all over 6, and then 5 minus 2 is 3 all over 7, then 6 minus 2 is 4 all over 8. So simplifying further, we have negative 1 minus 1 third. Mawawala na yan. So plus 1 all over 5 plus 1 third. Kasi 2 all over 6 can be simplified into 1 third. Then 3 all over 7. And then 4 all over 8 is 1 half. So makakancel na yan. The LCD here. The LCD is 70. Understood na may 1 yung denominator ni negative 1. 70 divided by 1 is 70 times negative 1 is 70 divided by 5 is 14. 14 times 1 is positive 70 divided by 7 is 10. 10 times 3 is 30. And 70 divided by 2 is 35. 35 times 1 is 30. Negative 70 plus 14 is negative 56 plus 30 is negative 26 and plus 35 is positive 9. So our the value of the series after evaluating it, we have 9 all over 70. So this is how we write a given summation to its summation form, to its expanded form, I mean. And if the upper bound is given, there is a value for its upper bound, we can evaluate it. Pero kapag walang value, variable lang siya, hindi natin siya pwedeng ma-evaluate, just like in this item. Understood? Example number 2, write the following series using sigma notation. For the solution, watch this video. In this example, we write the following series using sigma notation. So the first item we have 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17. So there are how many terms? We have 1, 2, 3, 4, 5, 6, and 7. So, ibig sabihin, mayroon tayong value ni upper limit. So, let's try to, the key in writing a given series to its equivalent sigma notation is that to identify a specific pattern kasi naghanap tayo ng formula. We're trying to rewrite the entire series using a formula, a specific formula. So, observing si 5, possible siya na ang kanyang 2 and 3 yung pinagsama. So, si 7 pwedeng 4 at 3. Si 9, we have 6 plus 3. And then si 11, we have 8 plus 3. Si 13, we have 10 plus 3. At si 15, we have 12 plus 3. So, as we can see, yung mga numbers dito, right before 3, ay multiples ni 2. So, yung second terms ng mga yan, si 3, pare-pareho, 3, 3, 3, 3, 3, and 3. So, paano kayo nakuha si 2? So, since multiple siya ni 2, 2 times 1 is 2. Si 4, multiple siya ni 2, we have 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, and 2 times 6 is 12. So, definitely, ang ating formula ay 2k plus 3 from, this will be 1, kasi 2 times 1 is 2. 1 up to 6. Or meron pa pala tayong 17 dito. We have 14 plus 3. So, the sigma notation for this one is 2k plus 3 from the summation of 2k plus 3 from 1 up to 7. So, for second item, we have 4, 1/4 plus 1/8 plus 1 all over 16 up to infinity. So, ibig sabihin, walang specific value yung ating upper limit. So, observing, nakita natin na yung mga denominators ay squares or powers siya ni 2. So, si 4 ay 2 squared, si 8 ay 2 cubed, at si 16 ay 2 raised to 4. So, meaning, mag-i-start tayo kay 2. So, this will be the summation of 1 all over 2 raised to k from 2 to infinity. Okay? Kasi, dire-diretso siya dyan. So, this is one possible answer for this series, one possible sigma notation for this series. So, kung makahanap pa tayo ng iba, much better. Like, for example, pwede nating i-write ito as the summation of 1 all over 2 raised to k plus 1 from 1 to infinity. Okay, acceptable din ito kasi as you can see, na-change yung kanyang lower limit. Kapag 1 yan, we have 1 plus 1 is 2. 1 all over 2 squared is 1 all over 4. Kapag 3 yan, kapag 2 yan, if k is 2, 2 plus 1 is 3, 2 cube is 8, so 1 all over 8. Same lang din sila. Okay, so, again, hindi lang isa yung sagot dito, maraming possible answer. So, for the next item, we have a sub 2 plus a sub 4 plus a sub 6 plus a sub 8 plus or up to a sub 20. So, as you can see, yung mga subscripts nila ay multiples ni 2. So, paano makukuha si 2? We have 2 times 1. Paano makukuha si 4? 2 times 2. Paano makukuha si 6? 2 times 3 and so on and so forth. So, ibig sabihin, ang kanyang sigma notation ay a sub 2k from 1 up to 10. So, paano nakuha yung 10? Ang factors ni 20 ay 2 at ni 10. So, ang last na term ay nakuha by multiplying 2 and 10. So, 10 yung ating upper bound. So, our answer will be the summation of a sub 2k from 1 to 10. For our fourth item, we have 4 all over 3 plus 9 all over 4 plus 16 all over 5 plus 25 all over 6 up to 81 all over 10. So, as you can see, paano nakuha yung may pattern siya. So, yung sa denominator increasing, nag-start siya kay 3. So, possible na ang ating summation ay mag-start sa yung lower limit niya ay 3. So, at ang kanyang denominator ay, syempre, k. So, yung denominator natin ay k. So, definitely, yung panghuling item ay yung kanyang upper limit ay 10. So, observing din na yung mga numbers na sa taas ay perfect squares. So, like si 4 ay si 2 squared. Si 9 ay 3 squared. Si 16 ay 4 squared. At si hanggang kay 81, which is 9 squared. So, from 3, paano tayo makakakuha ng 2? So, from this pattern, definitely, mayroong squared yung ating numerator. So, paano tayo makakakuha ng 2 from 3? Paano tayo makakakuha ng 3 from 4? Paano tayo makakakuha ng 4 from 5? So, definitely, nagbawas lang tayo ng isa doon sa ating value ni k. So, 3 minus 1 is 2, 4 minus 1 is 3, 5 minus 1 is 4, and 10 minus 1 is 9. So, definitely, we have k minus 1. 1. So meaning our sigma notation for item 4, we have the summation of k minus 1 squared all over k from 3 to 10. Understood? Take note. The sigma notation of a sum expression is not necessarily unique. So, ibig sabihin, kapag may given tayo na series and you are asked to identify or if you are asked to rewrite it in sigma notation, it's possible na makahanap kayo ng iba-ibang formula. So, for example, the last item in the preceding example can also be expressed in sigma notation as follows. So, 4 all over 3 plus 9 all over 4 up to 81 all over 10 is equal to the summation of I plus 1 squared all over I plus 2 from 1 to 8. So, let's proceed in the properties of sigma notation. So, definitely there are three properties. So, the first one is the summation of constant from 1 to n is equal to c times n. So, ibig sabihin, kapag nakita mo na constant term yung nandyan, we simply multiply that to the upper limit. So, for example, the summation of 5 from 1 to 8, since constant siya, minultiply lang natin siya doon sa upper limit, which is 8. 5 times 8 is 40. Take note of that. The second property is the summation of c times x sub I from 1 to n is equal to c times the summation of x sub I from 1 to n. So meaning, kapag nakita mo na mayroon yung ating summand, mayroon siyang numerical coefficient, pwede natin tong ilabas, pwede natin tong i-rewrite doon sa part before the summation symbol. Okay? So, for example, the summation of 2k squared from 1 to 3 is equivalent to, since nakita natin na mayroon siyang numerical coefficient na 2, nilabas natin siya, and then sinulot natin yung summation symbol from k squared, the summation of k squared from 1 to 3, then 2 times, sinubstitute na natin yung mga numbers from 1 to 3. What are those numbers? 1, 2, and 3. 1 squared is 1. 1 squared plus 2 squared plus 3 squared, or that is 2 times 1 squared is 1, 2 squared is 4, 3 squared is 9. So, adding this, it will give us 14. 2 times 14 is 28. Okay? For the third property, we have the summation of a sub I plus or minus b sub I from 1 to n is equal to summation of a sub I from 1 to n plus the summation of b sub I from 1 to n. So, meaning, kapag 2 or more terms yung summand natin, pwede natin silang i-write in this form. Pwede natin silang bigyan ng individual sigma notation nila as the summation symbol nila. Understood? For example, we have the summation of I squared minus I from 1 to 3. It can be written as the summation of I squared from 1 to 3 minus the summation of I from 1 to 3. Pwede natin silang paghiwalayin. We give them their individual summation symbol. And then, since 1 to 3, 3 numbers lang, we substitute 1, 2, and 3 sa kay I squared, and we substitute 1, 2, and 3 kay I. So, 1 squared plus 2 squared plus 3 squared minus 1 plus 2 plus 3. So, 1 squared is 1, 2 squared is 4, 3 squared is 9, and then 1 plus 2 plus 3 is 6. So, if we add this, it will give us 14. 14 minus 6 is 8. Understood? Let's proceed in this telescoping sum property. Ano nga bang telescoping sum? A telescoping sum is a sum in which subsequent terms cancel each other, leaving only initial and final terms. So, meaning telescoping siya kapag nakita natin, or telescoping series siya kung yung series natin nung inobserbahan natin siya, makakancel yung mga terms na nasa gitna, and then ang maiiwan lang ay yung term na nasa umpisa at yung term na nasa dulo. Okay, so we have this telescoping sum property. The summation of f of I plus 1 minus f of I from m to n is equivalent to f of n plus 1 minus f of m. So, sinubstitute natin dito sa unang term, Cn, n plus 1, at sinubstitute natin dun sa pangalawa, yung lower limit, which is m, f of m. So, for example, the summation of 2 all over n minus 1 minus 2 all over n from 2 to 5 is an example of a telescoping theory. So, paano ba malalaman? So, after substituting the values 2, 3, 4, and 5, so, ito yung lumabas. 2 minus 1 plus 1 minus 2 thirds plus 2 all over 3 minus 1 half plus 1 half minus 2 all over 5. So, if we try to remove the parentheses, okay, so may mga maka-cancel out yung mga nasa loob. So, like this one, negative 1 plus 1 is 0, na-cancel out. Negative 2 thirds plus 2 thirds, na-cancel out na rin. Negative 1 half plus 1 half, na-cancel out na rin. So, ang naiwan ay yung first term at last term niya. So, 2 minus 2 over 5. The LCD is 5. 5 divided by 1. Understood na lahat ng numbers may denominator na 1. 5 divided by 1 is 5 times 2 is 10. 5 divided by 5 is 1. 1 times 2 is 2. 10 minus 2 is 8 all over 5. So, this is an example of a telescoping sum. And then, yung telescoping sum property, magagamit yan mamaya sa isang example natin. Understood? Let's proceed in the sum of the powers of integers. So, here are the formula for the sum of the whole number powers of the natural numbers. So, meaning, applicable lang ito kapag yung start ng ating index, yung ating lower limit, start ng ating lower limit ay natural numbers, meaning mag-uumpisa siya sa 1. So, kapag nag-umpisa siya sa ibang numbers other than 1, hindi siya pwedeng gamitin. Hindi pwedeng gamitin yung mga formula na ito. So, here are they. Una, the summation of 1 from 1 to n is n. So, kung gagamitan ito ng property, yung unang property ng sigma notation, since constant siya, we just simply multiply that doon sa upper bound, which is n. 1 times n is n. So, expanded form, this is the expanded form. Yung pangalawang formula, summation of I from 1 to n is equivalent to n times n plus 1 all over 2. Yung formula niya ay ito. The expanded form is this one. Yung I squared, ito yung formula. Yung I cube, ito. Yung I raised to 4, ito. At yung I raised to 5 ay ito. So, yung mga succeeding formula, pwede yung ma-derive gamit ang telescoping sum property. So, makikita yan mamaya sa isang example natin. Okay? So, be mindful sa mga formula na ito. Example 3, evaluate the summation of 8i minus 4 from 1 to 15. For the solution, watch this video. In this example, we evaluate the summation of 8i minus 4 from 1 to 15. So, applying the properties of sigma notation, pwede natin silang paghiwalayin. This will be 8i minus 4, pwede natin silang paghiwalayin. Bibigyan natin sila ng separate summation symbol. We have the summation of 8i from 1 to 15 minus the summation of 4 from 1 to 15. Since mayroon tayong constant term dito, mayroon tayong numerical coefficient, pwede natin siyang ilabas. So, 8 times the summation of I from 1 to 15 minus, since constant term yung nandito, applying the first property, we just simply multiply 4 doon kay n. So, 4 times 15. So, 8. Since I siya, we make use of the formula summation of 1 to n times n plus 1 all over 2. So, this is the formula. Isa-substitute lang natin yung n, which is 15. So, we have 15. Then, 15 plus 1 is 16 all over 2. Then, minus 60, since 4 times 15 is 60. So, pwede na natin i-cancel out ito. We have 8 divided by 2 is 4. So, ang naiwan na lang ay 4 at si 15 at si 16 minus 16. So, multiplying further, this will give us 960, then minus 60. So, our answer will be 900. Understood? Example 4. Derive a formula for the summation of I squared from 1 to n using a telescoping sum with terms f of I is equal to I cubed. So, ito na yung sinasabi ko kanina na paggamit ng telescoping sum property in deriving a specific formula. So, for the solution, watch this video. In this example, we derive a formula for the summation of I squared from 1 to n using a telescoping sum with terms f of I is equal to I cube. Okay, so ang term daw ng mga ilalagay dito, we have f of I is equal to I cube. So let's try to use the telescoping sum for this one. So this will be, ating telescoping sum ay summation of f of n plus 1 minus f of I plus 1 minus f of I from m to n is equivalent to, we have f of n plus 1 minus f of m. So this is our telescoping sum property. So kung gagamitin natin siya sa part na to, this will become the summation of I plus 1 cube minus I cube from 1 to n. So, kung gagamitin natin yung telescoping sum property, this will give us n plus 1 cube minus 1 cube, since 1 yung value ng ating lower bound. Ang lower bound dito ay m. Since ang lower bound natin or lower limit natin dito ay 1, sinubstitute natin kay f of m si 1 cube, n, which is n plus 1 cube. So simplifying this, it will give us, simplifying this one will give us n plus 1 cube is n cube plus 3n squared plus 3n plus 1, and then we have minus 1 here, or maka-cancel out na yan, n cube plus 3n squared plus 3n. Equivalent niya if we use the telescoping sum property. But what will happen kapag in-expand natin ito? So we try to expand this and then we equate both results para minus I cube from 1 to n. So expand natin ito. This will become I cube plus 3i squared plus 3i plus 1. And then we have, kahit na hindi na natin lagyan ng parenthesis muna dito, close parenthesis, this will be minus I cube, or this will give us the summation of, mawala na yan, we have 3i squared plus 3i plus 1 from 1 to n. So applying the basic properties of the sigma notation, pwede natin silang paghiwa-hiwalayin, lalagyan natin sila ng separate sigma notation. This will become the summation of 3i squared from 1 to n plus the summation of 3i from 1 to n and the summation of 1 from 1 to n. So simplifying further, this will give us, since may constant term, may numerical coefficient siya, pwede natin siyang ilabas 3 times the summation of I squared from 1 to n. Same also here, may numerical coefficient, ilalabas natin siya 3 times the summation of I from 1 to n. And then this will be the summation of 1, or kapag constant yung nandyan, we simply multiply that doon sa upper limit. So n times 1 is n. So this will give us 3 times the summation of I squared from 1 to n plus 3 times. So we know the formula here. Ang formula para sa part na to, the summation of I, given na siya. So summation of I from 1 to n is equivalent to n times n plus 1 all over 2. So we have n and then n plus 1 all over 2, and then this will become plus n. So ito yung na-obtain natin after expanding this formula to be specific, the sigma notation. So take note of that. What will happen after natin silang kunin, after natin makuha yung paggamit natin ng telescoping sum property, yung result, at yung in-expand natin ito, anong gagawin dyan? So we will equate both. Okay, so i-equate natin siya. Okay, so pinag-equate natin yung dalawang nakuha natin. This one, ito yung nakuha natin after applying the telescoping sum property. Ito naman, ito yung nakuha natin nung in-expand natin yung sigma notation. So, this will be, since merong denominator na 2, we multiply all the sides by 2. So, this will be 2 times 3 is 6 times the summation of I squared plus from 1 to n. So, bakit natin ni-retain yung I squared? Kasi yan yung hinahanapan natin ng formula. So, plus, syempre, maka-cancel na yung denominator nito. So, this will be 3n times n plus 1. Then, 2 times n is 2n is equal to 2 times n cubed is 2n cubed. Then, 2 times 3n squared, that is 6n squared. Then, 2 times 3n is 6n. So, ita-transpose natin lahat ng to sa kabila, and then ang maiiwan lang sa side na to ay yung 6 times the summation of I squared from 1 to n. So this will be the summation of I squared, 6 times the summation of I squared from 1 to n is equal to, this will be 2n cubed plus 6n squared plus 6n. Then we transpose positive 2n, it will become negative 2n. Then ito transpose natin to, yung entire term na to, it will become negative 3n times n plus 1. So simplifying this, we have 2n cubed plus 6n squared. This will be 6 minus 2 is 4n, then minus 3n times n plus 1. So after that, yung portion na to, mayroon silang common factor which is 2n. So ilalabas natin si 2n. We have n squared. 6n squared divided by 2n is 3n. And then 4n divided by 2n is 2. And then we bring down negative 3n and n plus 1. So we bring down 2n. This is definitely factorable. Ang factors niya ay n plus 1 and n plus 2. So minus 3n times n plus 1. So, meron silang common factor. We have n and n plus 1. Kung i-arrange natin ito, it will give us pagsasamahin nito, ang may iwan dito ay si 2, and then si n plus 1, and then, n plus 2, and then minus n times n plus 1 times 3. So, kung ilalabas natin ito, ang may iwan na lang ay yung portion na to. So, kung ilalabas natin si n at si n plus 1, ang may iwan sa loob ay si 2 times n plus 2 at si negative 3. So, simplifying that, it will give us n plus 1. So, we distribute this one, we have 2n. 2 times 2 is 4. 4 minus 3 is positive 1. So, since mayroon pa tayong 6 doon, kapag i-divide natin yung entire side by 6 para maalis ito, it will give us the formula, the summation of I squared from 1 to n is equivalent to this formula. We have n times n plus 1 times 2n plus 1 all over 6. So this is how we derive a specific formula using the telescoping sum property. Understood? Example 5. Prove that the summation of 3i squared minus I minus 2 from 1 to n is equivalent to this formula, n times n plus 2 times n minus 1. For the solution, watch this video. In this example, we prove that the summation of 3i squared minus I minus 2 from 1 to n is equivalent to n times n plus 2 plus times n minus 1. So, we use the fact that the summation of I squared from 1 to n is equivalent to n times n plus 1 times 2n plus 1 all over 6. This is our formula for the summation of I squared. So, we bring down this one, the summation of 3i squared minus I minus 2 from 1 to n. So, paghihiwalay natin sila, bibigyan natin sila ng kanya-kanya nilang summation symbol. So, we have the summation of 3i squared from 1 to n and the summation of I from 1 to n and the summation of 2 from 1 to n. So, this will be, since may constant term dito, pwede natin siyang ilabas. And then we substitute, we use this one, since ito yung equivalent ni I squared, we have n times n plus 1 times 2n plus 1 all over 6. Ang formula for I, we have n times n plus 1 all over 2. And then we have 2n. Kasi constant term siya, we simply multiply it. It by n. So, mawawala na to. This will become 2. So, we have n times n plus 1 times 2n plus 1 all over 2 minus n times n plus 1 all over 2 and then minus 2n. N all over n plus 1 all over 2. And then, since as you can see, meron silang parehong n all over 2, n all over 2. Para magkaroon ng n all over 2 ito, we reverse it back. Before ma-simplify, we have 4 n all over 2 para siya magkaroon ng n all over 2. So, ilalabas natin si n all over 2. We have, may iwan na lang ay si n plus 1, si 2n plus 1, and then si n plus 1, and then si, kung nilabas si n all over 2, may iwan dito ay si 4. So, we bring down n all over 2, and then get the product of this one. We have 2n squared plus n plus 2n plus 1. Then we distribute negative 1 to all the terms. Inside the parentheses, we have negative n minus 1 and then minus 4. other terms, mawawala na yan. Mawawala na rin ito. Ang maiwan ay 2n squared plus 2n minus 4. So, ilalabas natin si 2 dito. So, we have 2n all over 2. So, nawala na yung 2. We have n squared plus n minus 2. So, if we factor this out, ang factors niya, we just copy n. Since yun naman yung naiwan after cancelling 2. Factors of this, we have n plus 1 or n plus 2. Factors of this, we have n plus 2 and n minus 1. Since naipakita natin na the summation of 3i squared minus I minus 2 from 1 to n ay equivalent kay n times n plus 2 times n minus 1. We say, therefore, the summation of 3i squared minus I minus 2 from 1 to n ay equivalent kay n times n plus 2 times n minus 1. Understood? Example number 6. Evaluate the summation of 1 all over I plus 4 minus 1 all over I plus 5 from 25 to 150. For the solution, watch this video. For this example, we evaluate the summation of 1 all over I plus 4 minus 1 all over I plus 5 from 25 to 150. So, itry ka natin i-expand. So, the 1 all over I plus 4 minus 1 all over I plus 5. So, if I is 25, then we have 1 all over 25 plus 4 is 29. And then, 25 plus 5 is 30. If I is 26, then we have 26 plus 4 is 30. And then, 26 plus 5 is 31. Plus, if I is 27, then we have 27 plus 4 is 31. And 27 plus 5 is 32. Up to if I is 149, then 149 plus 4 is 153. If I is 149, then 149 plus 5 is 154. And lastly, if I keep on saying n. If I is 150, then 150 plus 4 is 154 minus 150 plus 5 is 155. So, since if we observe the terms, may mga makakancel out dyan. Like, for example, si negative 130 and 130, negative 131 and 131. At kapag kinontinue natin yung process, which is very taxing kasi madaming terms yung from 25 to 150, kapag diniretso natin yon, makikita natin na makakancel lahat. Ang may iwan lang ay yung first term at yung una at yung huli. So, definitely, this is an example of a telescoping series. So, makakancel na yan. Makakancel na yan panigurado. Makakancel na rin ito for sure kapag kinontinue natin. Ang may iwan na lang ay si 1 all over 29 at si 1 all over 155. So, we obtain the LCD. The LCD here is for 4,495. 4495 divided by 29 is 155. 4495 divided by 155 is 29. So if we try to subtract the numerator, we have 126 all over 4,495. This is our answer. Understood? For the last example, example 7, find the sum of the summation of 3k minus 2 from 15 to 100. So ito yung example na kung saan before natin gamitin yung sum of the power of the sum of the powers of integers, bago natin yung gamitin, kailangan muna natin siyang i-write in terms of natural numbers. So meaning dapat mapalitan ito ng 1. Kasi hindi pwedeng gamitin yung mga formula na nandun kapag hindi 1 yung starting point or uh, yung lower limit natin. So for the solution, watch this video. In this example, we find the sum of the summation of 3k minus 2 from 15 to 100. So applying of the property of sigma notation, properties of sigma notation, yung one property doon, we can separate this one into two different terms. Lalagyan natin sila ng kanya-kanya nilang summation symbol. So this will be summation of 3k minus 2 from 50 to 100 is the same as the summation of 3 3 times the summation of k, since constant siya, pwede natin siyang ilabas agad. 3 times the summation of k from 15 to 100 minus the summation of 2 from 15 to 100. Since yung starting point or yung lower limit natin ay hindi 1, hindi natin siya pwedeng gamitan ng mga formulas natin, which are the sum of the powers of integers. Hindi natin siya pwedeng gamitan. So kailangan muna natin siyang i-change yung I from 15 to 100. So kapag i-change natin yan, for example, the summation of k from 15 to 100, same lang siya ni summation ni k from 1 to 100, at ibabawas dyan yung summation the formula. So this will be 3 times, yung formula nito ay, again, the formula is the summation of I from 1 to n is equivalent to n times n plus 1 all over 2. Take note of the formula. So this will be, the value of n is 100. So 100 times 100 plus 1 is 101 all over 2 minus, this will be 14 plus 1 is 15 all over 2. And then yung dito sa part na to, we have the lower limit, if the value of the lower limit is 1, take note of that. Kapag nakita mo na hindi siya equivalent kay 1, kailangan mo pa siyang i-change into 1 para ma-apply mo yung mga formulas na yun. Understood? For the activities, do activity 2 on page 29, activity 3 on page 29, activity 4 on page 30, activity 5, items 2 and 3 only on page 30, and activity 6 on page 31. Submission of all outputs will be until Monday.